Okay, we're live. So, welcome everyone to today's TechNovation talk, entitled "Predicting Human Behavior Through Analysis of Online Conversations." And the talk is going to be given by Professor Sao, that I worked with before. We've had some very nice experiences working on UN projects, and in fact, one of Professor Sao's students is in the back, UA. Yes. And I wanted to mention a quick story about a collaboration that we had with Fordham University. We had a presentation at Fordham with a few UN agencies, and we explained projects. And a lot of students became really excited about using data analytics and data science and business intelligence to help the UN achieve our goals. And we started many projects with them. But one project, the one that UA and Professor Sao participated in, went from a concept and an idea that we had at the UN to a tool that is now online and that was presented at a global forum organized by the ITU in Geneva, highlighted as a good collaboration between academia and the UN. And there was a tool produced, and there were no funds expended by anyone, by neither the school or the agencies or the YCT spent any money. That was a really good experience, and I thank you again for that. And so I will just give a very brief introduction about yourself, so we can go into the topic. So Professor Sao is a PhD associate professor at Gabelli Business School at Fordham University here in New York. Her research interests include business intelligence, web, text, data mining, multilingual knowledge discovery, and human-computer interaction. And I will stop there and go into the topic.
Great, thank you very much, George. Thank you for the invitation here. It's my honor to be here, and we had some great collaborations. Today's talk is going to focus on text mining approaches to analyze websites and social media. And in particular, I'm going to present two case studies. Now, before I get into these two case studies, I want to talk about the text mining tasks here. How many audience here have know about text mining? Have you heard of text mining? Oh, okay, great. We have a good number of people. So I want to introduce, this is a text mining pyramid that we created, sort of summarize the different level of tasks and their business value. From the very bottom, so text mining is trying to understand trends and extract information from text. Yes? Oh. It is better? Okay. So it has a lot of interesting applications. From the bottom, we have finding topics, and this has been used by a lot of business. For example, you're trying to see what are the trends on social media. You try to identify hot topics on Twitter or Instagram by looking at the occurrence or appearance of certain keywords and how many mentions you can extract from keywords. So these are part of finding topics. And then there's sentiment analysis, understand user positive or negative sentiment toward a product. And this has been used in marketing area, also in political science, looking at the voter sentiment for certain candidates, and also even in finance. People look at sentiment in news articles, trying to predict company performance and the stock performance. So that's the sentiment analysis. And a level on top of sentiments is what I call emotions. So sentiments only look at the positive and the negatives, but actually you can express a lot more than just the positive and negative. It could be, so for example, in one of the case study, we look at violence level and the racism level. Okay, so there are different emotions that you capture, depends on your business needs. And then the second study that I'll talk about focus on speech acts and interactions. Most existing text mining research only look at the semantics of the text. Okay? Few of them look into the syntax, and few of them look into the pragmatic. People say things for a reason. They have a pragmatic behind it. And that's what we try to discover using a series called Speech Act. We try to see what exactly they try to express. So that's the first level, and on top of it, there are other interesting things that you can do. For example, event detecting, and trying to figure out what time, at what place, what has happened, who talked to whom or who went to what place. So event detection, and there's user modeling, personality traits, demographics, and there are other emerging tasks and and use cases. Okay. So the data available, or text mining technique availability goes from more available to less available on this pyramid, but the business value also increase when you go to the emerging tasks and the top of the pyramid. So that sort of set up a tone of the different tasks or different projects that I'm going to introduce today. The first case study I want to introduce pretty much focus on the bottom 3 levels, the topics, the sentiment, and we also do some network analysis. This is a case study where we collect web pages and also social media, for example, forum and chat room message, try to understand the performance of extremists. Okay? And in particular, we ask these questions: who linked to whom and who influenced whom? Okay, in terms of the extremist groups. How are the sites used? So what do they put? What content do they put on these websites? And which sites are more sophisticated? Okay. It's a collaborative work with several other colleagues. So this is a diagram called social network analysis diagram. So what we did here is that we collected in this case, this diagram is Middle Eastern extremist groups, their websites. So on every website, there are HTTP links, the reference to other websites. They cite information from other websites. Okay. So we crawl all these websites and we analyze their linkage. Okay. There are a lot of linkage because every page has over 100 linkage. Very often, some of them link to themselves, some of them link to outside websites. Okay, and then we use visualization tool written in Java to visualize the network among all these extremist groups. Okay, now the original network is very complicated. There are a lot of links. You can imagine if you draw every single HTTP link possibly between all these extremist groups. We use an algorithm called MDS. It's an hierarchical clustering algorithm, trying to cluster some of the links so that we can see a bigger picture of who is connecting to whom. And this is what we have. So each dot here represents a website, an extremist website. And the link represents how often they reference to each other. So in a way, they may share similar ideology, or they like to reference each other. And we have somebody with from political science trying to circle the groups that she can identify. So we can see that they really form certain web communities. So here is, one group of extremists. So these are the jihad supporters. So they form a web community here. If you calculate the extremeness of these nodes, you will find that they are in the same community. And then we have Palestinian supporters and extremists. So this is on a very high level. We haven't get into the content yet, but we're just looking at the links. You get a high level of how they are connected to each other. Okay. Next, we try to look at what do they say on their websites. So we crawl all the content. We also look at the technique that they use on the websites. And we're comparing US domestic and the Middle Eastern websites in terms of several type of contents: communications, fundraising, ideology, propaganda to insiders, propaganda to outsiders, virtual community. So if they have like online web forums that allow their group members to talk to each other, command and control, and recruitment and training. So for each of these dimension, we actually have a list of things. So we first have expert tagging the document, trying to figure out. So for example, communication, usually there is a form on the web page that they can submit something, or they can email something, or they can communicate through a chat room. Sometimes there's a chat room on the website. Okay, and then we find what other technologies that support each of the tasks. Okay, and we go through every website, try so there are a number of different groups, and you can see, for example, communication, which is this sign. So we have eco-terrorism. This is pretty high on communication, and several other groups are lower. And here we have the Palestinian group that's very high on this dimension, which is recruitment and training. So they have a lot of information on their websites about recruitment and training compared to some other groups. So you kind of get an overall idea about what each website talks about and their focus. Okay, so if we look at fundraising, which is this sign here, you can see actually in general, the Arab and the Middle Eastern groups actually have a slightly higher level of fundraising compared to the US groups. Okay, so that's the content level. And then we look a little further into the web forums. Okay, so the website is one entity, the forums is another entity. So we collected, this is an example of the different groups that we collected. Again, we look at what they talk about in terms of content. We code them into links to other terrorist websites, messages from other extremist groups, ideology discussion, and computer virus. And we try to code, and this is also done automatically once we have trained our algorithm, how, what is mentioned within each forum. And these are just statistics of how many members and how many postings we have on each forum. And the next thing, we try to group these topics using a visualization tool called SOM, self-organizing map. Behind it, it's a two-layer neural network that can cluster topics together. So you kind of get an idea of what is being discussed on the forum, and you can click on each of the region to see the actual topics, and it also gives you subtopics. Now, because this is automatically generated in real time, not every region makes sense. Okay, so you kind of have to navigate to see what interests you. So you see that they also discuss about technologies, besides ideologies and other things. So at this step, it's all at content level. We're looking at the semantics, what they're talking about. The next slide is an example of what we can do with sentiment and emotion analysis. And this is also based on US and Middle Eastern forums. We look at two dimensions. One is called racism, and the other one is called violence. So we look at how intense each dimension is for every forum from different groups. Okay, and the way we calculate them is that we look at a dictionary of words that represent racism and violence, and we also look at sentence syntax. We look at about 50 different attributes to generate the final result. So, for example, in US, we also look at punctuation mark and the way they emphasize each word. So, in Arabic, we look at patterns such as elongation and other special patterns. We're working with an Arabic-speaking expert. And then you can see that they are really different in terms of the level of racism and violence. And we have one forum here that has much higher racism intensity compared to all other forums. And so is the violence. So probably this is a forum that we should pay more attention to compared to the others, just because of the level of the intensity. Okay. Now, we did a lot of other studies, but for the interest of time, I thought I'd give you some examples of what we worked on in terms of finding patterns and their dialogues on extremist websites and forums. Okay. Now, we haven't get into the linkage between actual messages yet. At this point, we looked at the linkage between websites, but we didn't know individuals who talk to who. Okay, so in the next case study, I want to give you another example that is a little more advanced in terms of technique. We worked with a telecommunication company to solve their social media analytics challenge, and George and I discussed, and we think this is a good example because it gives you an idea of what system can be used if you want to have real-time analytics. Okay. And this is motivated by this anonymous company. We can't release the name. It's one of the 10 largest telecommunication company, and they have a social media team of over 20 people. They analyze over 43,000 messages every day between these 20 members, so that's a lot of messages to read. They have some simple analytics tools, such as counting the number of keywords, looking at which keyword appear most in social media today. So they have some simple statistics tools, but nothing too advanced. And they were happy with it until 2012. They had a crisis. They started a new plan where they get to the premium members that they increase their speed. Okay, and that's only about 20% of the customers. Okay, so within 24 hours, they saw discussions. They look at the 2,000 new discussions, and the overall sentiment is positive. So they were using standard sentiment analysis tools. And most of these tools look at the number of positive words versus the number of negative words. So very straightforward approach. Okay. They were happy. They think their plan is working within 24 hours. The next 54 hours is the nightmare. The word starts to spread to the other 80% of customers who did not receive the premium package. So they thought these customers were very angry, and they start to complain on social media, and they start to leave the company. But it's too late for the company to retain these customers. So as a result, they have an estimated loss of 110 million. In terms of revenue, because customers leave, customers churn. And that's a huge problem with a telecommunication company. And the churn rate increased 5 times. So that's when they panic. They think that their social media team is not capturing the information in time, because within 24 hours, they were not able to see the issue. And that's where we came in, that we want to do something that will help them better discover the issue. And this is what we try to build when we look at their issue. So this is typical messages that we see on social media. Okay, and we try to reconstruct this information by creating a tree structure. So if you think about social media message, they're intertwined. So you may be replying to somebody's posting 2 days ago, okay, or 5 messages ago, okay, but you're not getting the actual structure of the conversation. And I'll show you why understanding the actual structure is important, because you want to know who is playing the key role in the discussion. Okay, so the first thing we want to do is to reconstruct a tree-like structure for all the conversations. And furthermore, we want to identify speech act of each conversation. If you look at the small icons in front of each message, each posting, these are the different speech acts. So it tells you whether the customer is has a suggestion, or whether the customer have a strong expression, or whether they agree with something. Okay, so we want to understand their speech act as well. And these are the 5 speech acts we use: assertions, directive suggestion, directive question, permissive, and expressive. Why is that? Okay. Here are some examples of how this structured information can help us identify issues and the key players. If we know their actual conversation structure, if we know who is replying to which message, okay, we can construct a network between the participants. Otherwise, your network will be, if you use a chronological order, your network will be completely wrong. Okay, so first of all, you have to understand who is replying to who in the network. Okay. Now, by constructing the network, we can use SNA to find the key players in the conversation, in the discussion. So that's our first task. Second task, we can find potential issues by looking at the speech act. So the expressive and the directive question, they are directly related to potential issues. So for example, what new products exactly? Easier said than done. So this is an example that they saw on social media. Okay. If you look at the sentiment, you may not really generate positive or negative sentiment. But if you look at the speech act, it is an expressive speech act. So the user is expressing that he or she is not happy with it. So these are the messages that we plan could help us identify potential issues. And then there are suggestions. So this is what they need. We need aggressive advertising and the promotions. Okay? So this will help the analyst to monitor the online messages and conversations easier. So this is our big picture of what we want to do to help them. If we look at the different types of social media, okay, there's Facebook, there's web forum, there's Twitter. There are a lot more, but I'm using these 3 as examples. And this is in general how the messages are structured. You have, different users, here 6 users, okay, and they may be discussing different topics. So if we read these messages, we really find here 6 different topics that they discuss. Okay, and similar here in social networking, Facebook. So our first task is to be able to identify topics. We call it disentanglement, conversation disentanglement, because the topic is not only based on the similarity of messages. Okay, we also look at the connection between messages, because there is a relation between a reply and a question. So that's the first task, is to find the primitive messages so that we can disentangle the conversation. The second task is to reconstruct the reply-to relationship, to understand who is talking to whom in the message. And it's a common problem in all social media. Although you would see something like Facebook, because you can reply to a certain message, and you think ideally, if I'm replying, let's say I'm replying to George, I should follow that structure. But most users don't. They just type the message whenever they want. So that's why with any type of social media format, we want to reconstruct the relationship, and that's what we call coherence analysis. Okay, so these are the 2 components that we work on, and then we do a classification of speech acts. There are 5 classes, like I discussed before: assertive, permissive, expressive, declarative, and directive. Okay. I have several slides on some of the technical details. I think I'm just going to focus on this overview of framework, and then I'll be brief on the actual implementation. So we start with discussion messages here. Okay, they're intertwined. Okay, they're messy. Okay, there are 2 tasks here. conversation disentanglement and coherence analysis. Okay, during conversation disentanglement, we have two subtasks. One is to find the primitive message. Primitive message is the first message in a topic. So somebody starts a new topic. Okay, so that's our first task. The second task is to find messages that belongs to that primitive message, that belongs to that topic. And we use the number of similarity algorithms there. Okay. So after these two steps, we can divide the messages. We know, these are the messages belong to this certain topic. Okay. And that information is sent to the second component called coherence analysis. The goal of coherence analysis is that within each topic, we want to know which is the first topic, of course, the primitive topic, and who replies to the primitive topic. And afterwards, which message replied to which message. We use a classification algorithm that we built. It's called a composite kernel classifier. It's a SVM algorithm, but then we rewrite the kernel. Based on three types of features. System feature, these are very standard. When you reply to somebody, when you quote somebody, or when you ask somebody, it's clear in the system. We don't need to do any analysis. We just need to extract that system feature. So this is if all users are following the rules of Facebook or forum. Okay, but in the chat room, you don't have that rule. Okay, so that's the system feature. The second feature is called linguistic feature. In the linguistic feature, we do some reference analysis. So let's say you call somebody's name Peter. Okay, it's not in the system, but it's in the conversation. Then we extract that name. We find that, hey, this is the user Peter. Okay, so we make the connection. This is what we call linguistic feature. There are several other linguistic features, but in general, these are simple rules that you can implement, mainly based on references and the appearance of the exact same word. The last type of feature is what we call conversation structure feature, and this is information that we get from the primitive message and affiliation messages, okay, from the disentanglement. Specifically, we look at the similarities between messages on different levels. Okay. So after that, we have the coherence. Okay. And then together, the last step, we will create the SA tree, which is the tree structure of the conversation. Okay. And on the bottom, we do a speech act classification, also based on SVM. So that's the general structure. This is a diagram that shows you how we did the disentanglement. Basically, we put the messages into bins, different bins, and there's a bin size that we assign, and we look at the similarity between the current message and any other bins ahead of the message and any other bins after the message. So if this message belongs to a topic ahead of it, it should be more similar to any messages here than any messages after this message. Okay, but there are a lot of tuning and refining in this similarity comparison. So we revised the similarity comparison message, and we use TF-IDF, and we use a bunch of different mechanisms to make sure that we assign this message to the right thing. I'm going to be a little brief on this detection part. In the coherence analysis, I listed a bunch of features that we use within each feature category: the system feature, the linguistic feature, and the conversation structure feature. So for each category, we actually break down into a number of other features. So for example, I mentioned the co-reference and the direct address in the linguistic features. We also use sentiment polarity in the linguistic features. Okay, so that shows you some coherence in the messages. So that's the coherence analysis. And the classifier, we modified the SVM classifier because most SVM classifier use an RBF function, but we changed it to a tree structure kernel function. The idea is to find the probability between the messages. Okay, if this message D is a child of message A, meaning that D replies to A, then this pattern should be a pattern that we observe in other messages. So let's say a directive is this directive message. Assume that this is a directive message, and this is an expressive message. If they compose a reply to message, that pattern should be observed in other messages. So that's the basic idea of the kernel tree function, is that we create this SVM kernel and then we modify each subtree based on their probability of appearance. So that's the speech act classifier. And these are the details of how we develop the kernel function. So once we finished the system, we did a series of studies. We did the simulation test, trying to look at the performance of each component, the coherence and the disentanglement algorithm in comparison with other algorithms, such as clustering and other classification algorithms. We also did a user study. We recruited 100 users, asked them to tag the messages manually and compare their tagging results to what system generated. So that's the second user study. The third study is what we call a field study, and I found this study to be most interesting. So I'm presenting this study here. We did a 4-month A/B test with the telecom company. And we want to see if our system is really helping them compared to their existing system. So we had 23 members monitoring social media. That's their social media analytics team. We divide them into 2 groups. 12 members using the existing system. So looking at the sentiment, looking at the occurrence of keywords, and 11 members assigned to our system called LTAS. Okay. They're not co-located and only had access to their respective system. Okay. So during this 4-month period, the entire team received over 5.2 million social media messages. Okay. So this is from all different types of social media. And this is how we designed the study. So these are the different social media channels that they receive message. Okay. And our evaluation metrics is listed on the bottom. So there are several different key players here. There's the analyst, okay, the monitoring team. There's the customer support, technical support, and the managers. Okay. So when we receive these messages, we have 3 tasks for them. Identify issues, so unresolved issues and high-risk customers. The second one is to identify key users, who is a key participant, and also identify ideas, popular suggestions. So all 3 tasks are goals that when we design how we design the system. Okay. So as an analyst, we look at how many threads does the analyst browse, okay, the usage, and how do they rank the participants, and how did they do the conversation filters, and then they generate reports. So they report the number of unresolved issues, high-risk customers, key participants. We look at their productivity in terms of ticket volume and the report timeliness, okay, how fast they can react. And last, we look at their ticket creation, and we look at 3 other aspects: their customer support, okay, customer engagement, key user engagement, and whether they can resolve the issue. Okay, their technical support, okay, also their management, okay, review of suggestions, and also larger issue resolution. And here we relate to their business value, okay, because each issue resolved relates to their customer retention. So we look at how many customers that they are able to retain because of resolving issues. So that's these are on the bottom are the matrix that we use, and then on the top is the process of how we generate these matrix. In the A/B test, so this is the existing system A, and system B is our system, and these are the 4 items that we calculate: timeliness, ticket volume, issue resolution, and the customer retention. Okay, so we differentiate them from system B reports only, system A reports only, and this middle part is where both of them report. So our value really is in system B minus OK minus system A only. That's how we calculate the performance, and this is a summary. So on the top part, we did several surveys, asked the analysts to rate the usefulness of our system. So you can see pretty much our system is ranked higher than their existing system, except for one part, ease of system use. Okay. And then on the second part, this is where we measure the productivity. So you can see timeliness, okay, 30 versus 84. Okay. And then ticket volume result, okay, also higher volume, with all different perspectives, and issue resolution in terms of business value, we were able to create 13 million versus system A is 9 million. So overall, we can create 4 million compared to their existing system. And customer retention, 7 million versus 4 million. So that's how we evaluate the system. Okay. I guess that's my introduction of 2 cases that I would like to welcome questions or discussions from the audience. Any questions? Yes, sure.
Start. I'm thinking, thanks for these examples. This is very interesting. I'm thinking how these cases could be generalized for the kind of analysis that we need to do.
Mm-hmm.
And you're looking here at sentiment analysis of these customer conversations,
mm-hmm.
finding groups in that. So we've done a little bit of sentiment analysis to see what are people in Northern Africa thinking about global warming, etc. If we wanted to take something like that to the next level, to say, are there threats in these discussions or groups in these discussions, what would be the next step for us to take on?
Mm-hmm. So I guess if we are looking at group discussions, well, on the first level, we can try to figure out the key players, the key participants in the discussions. Okay? Because you may have, 10 people agree on this topic and 1 people against the topic, but it could be that that 1 person is quite important, is a more influential member of the discussion. So one thing that we can really look at these discussions, trying to find out who is a key customer, who is a key user here. So we're trying to find key customers, and then in your case, it may be finding the key users. And then second, aside from finding sentiment, maybe we can go 1 step further. We can look at what these sentiments are associated with. Because climate issue, there may be a lot of other subcategories that they discuss. And we can also see, for example, if it's a long topic, we can also see the topic trend if you do the conversation disentanglement. So you sort of list the subtopics that are being discussed there, and you can find the sentiment on each subtopic. Now, versus if you are doing an overall sentiment analysis, the result is quite general because it's on 1 big topic. Okay, but if you disentangle the dialogues, you can really see why they agree or disagree on something, and maybe even the intensity of their sentiment. So with more advanced technology, we can do more advanced analysis, try to get into more depth of the content.
The web forums that you analyze, I assume they have a couple of thousand members of each forum, maybe 100. Would such an approach work if you take, for example, the Twitter firehose or Facebook or something like that with millions of users?
Yes, we actually, so in this example, we sort of limit the scope millions of messages and even 10 millions of messages. So the reason we cannot do a whole bunch of messages because we have to have human to tag the messages so that we get the gold standard. So but if you look at in the field study, our system is used on 5.2 million messages, and that's really not our limitation. So the first part when we try to develop the model, when we're trying to do the training and testing, we limit it to a smaller data set. But when you have the use case, as long as we have the computing power, that shouldn't be a limit. Yeah. And actually, when the data set is bigger, because text mining, pretty much you're looking for trend. So when you have a large amount of text, the trend is more obvious than you have a smaller amount because there's a lot of noise. So when the text is big enough, it sort of cancels all the noise, and then you have a better prediction. Yeah. So that's the data science question. Thank you. Yes, please.
Two questions. One is about the text mining, the sentiment analysis. I think it's probably quite simple if it's a positive or a negative sentiment about something. I think vocabularies or dictionaries are available for that in popular packages. But what if you want to go a step further and you want to know what is the character of the people who are putting towards these texts, even not short text messages, but longer or bigger text? Are there more advanced dictionaries for that would classify the character of somebody from whom the text is originated from?
Yes. So the simplest way is to use a dictionary, and usually you get a pretty mediocre performance, like 60-some%, or maybe at most 70-some%. If you want to improve the performance, the first question to ask is whether this is on a particular domain. Because if it's any text, then the performance is usually not that good. But if it is on a particular domain, okay, then you can train a classifier. Okay, so in one of my research, we did an SVM classifier together with SVD technology, and we were able to achieve like 90-some performance. Okay. Two, you can think about what other features that you use. So in the extremist example, we actually had what we call authorship analysis, but we're trying to define different features of an author. So for example, the writing style. Okay, so it's not just the words, it's also the writing style. It's the punctuation that the author used. It's the context. So you look at words and in combination with other words. It's also so in the writing style, we look at, for example, 10 other items. How the number of vocabulary an author use. So there is a potential to expand a simple dictionary approach to a much richer set of dimensions or features. So really, it's I think the algorithm is very standard. Usually, SVM works best for a classification-based sentiment analysis. But the key is what feature you are using and how do you select the most relevant feature for your domain. So that's pretty much the key to improve sentiment analysis. And then there's also a line of research work on feature-based sentiment analysis, sort of go back to the Africa question. So instead of knowing that the sentence is positive, I want to know this sentence is positive on what issue. Because I may like iPhone, okay, but I may hate the price of iPhone. I may like the camera feature of iPhone. So it's a combination of positive and the negative that you try to extract. So that's another level of sentiment analysis. Did I answer your question? Okay, you say you have a second question.
Yeah, I give the floor.
Okay. Yes, please.
Just quick two questions. You already said you picked up a couple of examples as analysis, Facebook, Twitter. But I just want to know what kind of SNS you have been testing or analyzing, like Slack, Telegram, other media.
So we
Just particular focus. Mine is some of them are really strongly encrypted. Is it possible?
Yeah, sure. So we so in the testing we worked on 5 different data sets. We worked on healthcare, telecommunication, a marketing company, and also security issue. And for each topic, we collect information from 3 to 4 different social media, including Facebook, Twitter, and also online discussions. So and also forums. Yeah, as long as the information is available. So we had a total of over 15 different data sets when we test the algorithm. But then the field study is based on the telecommunication.
Yeah, I was just wondering, for example, terrorists or illegal activists, they don't really use the open social media.
Oh,
They go into the maybe Signal or Discord.
Okay, so in the second case study, we didn't look into terrorists or extremists. In the first case study, when we started, we actually spent 1 year just to identify the forums and the websites, because they use robot exclusion. So that search engines do not index them, they do not crawl them, and they are all hidden. So the way to look for it is really try to find information on forums and use backlink search to find these websites. So that's another set of techniques that we use to try to identify these forums and websites. But it was very tedious. We couldn't find a very systematic way or an automated way to find them. So it's pretty much based on a combination of human and backlink search. Yeah.
Thank you.
You're welcome. Any other questions? Yes, please.
Yeah, so my question is more to do with the availability of some of the techniques, maybe like the speech act classifier that you showed in the previous slides. For a lot of people, they probably would find the underlying algorithms a lot more difficult to work with and to actually model on their own. Are any of this available as open source, maybe as something like you could use to train your own models, or use dictionaries that are already, like we do for sentiment analysis and other forms of text analysis?
I think the Speech Act is not available. We actually just published this paper a couple months ago. So we have the algorithm, but we have not commercialized it. We did have some collaborations with companies. So if you look at this diagram, really most of the commercial software focus on the topics and the sentiments. Even when you want to go to emotions, you will find very rare software that gives you emotions. There are some software that provide personal traits and the big five analysis, but I found most of them based on dictionary and are not quite accurate. So that's, if you're asking about commercial tools, that's the situation. And we're hoping, in the near future, maybe we can commercialize our speech act app.
Any chance of open source or commercialized?
Right now, it's not open source. We're doing it as a research project, so we haven't made it open source. But that may be a good direction to go for. Talk to my co-authors about it.
Yes. How do you obtain the data sources? Do you get it, for example, let's imagine an entire WhatsApp conversation, I mean a group conversation. It's supposed to be private and encrypted. So how do you get it? How do you get? Do you ask the communication provider? Do you ask Verizon? Do you ask NSA? I mean, how do you get it? I mean, once you get it, you can apply your algorithms and do whatever you like. But you need to have the source, right?
Right.
So how do you get it?
So for the chat room data, we actually have to get it from the company. We cannot crawl it. We can only crawl social media, forum data, and websites, because chat room is real time. So we have two chat room data. One is from a marketing company, and one is from the telecommunication company. In both cases, we have to get it from the company. So that's the only data. You're right. That's the only data source that we cannot crawl. Yeah. Yes.
Yes. Small question for you. Thank you very much. It's a very interesting, very inspiring presentation. Is there any way, let's say, to use the system as a preventive way, in a preventive way, let's say, to avoid, let's say, having sentiment trading? I'm just looking at the news in the last, let's say, 2-3 weeks. Let's say what's happening in Myanmar. And then you can see that in some of the forums, people start talking, and we have, let's say, pictures being sent all over the place. And then you ask yourself, it's like, we're in sentiment now. Let's say to take action. I'm just wondering, is there any way to use some of these systems to prevent that from happening, because it's building now?
Yeah, very much. So in the extremist analysis example, we actually also did event analysis. But I didn't put it in the slides because of time constraint. So we look at the sentiment in the forum and how it changed a long time, and we see that during several events, for example, some of the beheading events, and also when the U.S. government has new policies, you start to see a race of sentiment, a race of emotions in the forums, and you also see race of forum postings, and you start to see other words, interesting words mentioned in these forums. So absolutely, I think these can be used for prevention purpose, and that's exactly why we want to develop this in real time to understand the level of violence and racism, because the change of the level is an indicator.
Just a follow-up question. On your pyramid, the pyramid, let's say the maturity model you're using, is there a way to link it with action also? And just, let's say, when you look at it, let's say there should be also a flip side of it, and you see the action taking place. Some of the, let's say, levels you have there, yeah, it starts from topic, sentiment, emotion, speech, and then you have event. For me, let's say between the speech acts and the event, there should be some action at that level. So let's say if I reverse this pyramid, so I would have, let's say, from inspiration to action, and that's where you have also to start, let's say, having some preventive measures.
That's a very great question. So that's actually going from predictive to prescriptive analysis. And in both studies, I think we didn't have a prescriptive mechanism because we're developing the system as a decision support. So we are supporting information that will help managers or analysts to make quicker and easier decisions. But then the reaction, I think, that's a very interesting part, and we'll have to work with the managers to understand what is their role, what is their thinking process of making reactions, and then we can have, other mechanisms that's designed into the system. Thank you, very good question. Any other questions?
Yeah, time for just maybe one more question, and then we'll wrap it up. Does anyone have any last question? Okay. In that case, can I ask for a round of applause for yes? And I would like to make you some housekeeping announcements about the TechNovation talks. Well, about this talk. YCT has, in collaboration with partners such as Forum and some private sector companies, ways to address some of your text analytics problems. If you have any questions or want to try out some experiments, we can look at your data and we can link you up with Professor and other partners to see what they can do for you. As I mentioned before, we had a really good experience with Forum before. That's one point. And the next point is that we hope that you continue coming to these talks. They are of very different ranges of technologies and topics. And the next one is on October 3rd, October 3 on cryptocurrencies, Bitcoin, Ether, and other forms of electronic currencies. That is very much a lot of people have questions about that these days. And after that, we'll have a few talks on artificial intelligence, Internet of Things, and those should be quite interesting as well. Thank you all for being here. To the participants that are looking at this TechNovation talk online, I apologize for the bandwidth issues that we were having. The whole recording of the video, high definition, will be available shortly, as well as the slides. So thank you everyone for coming today, and thank you, Professor Cloud.
Thank you very much. And thanks for the opportunity for collaborate. Our students like the UN project a lot. They find them to be very useful. Thank you. Great. And we welcome for future collaborations as well. Thank you.